Okay, so my topic today will be digital sustainability of open source communities. As you are an open source community, I think this fits the topic, but you are much more than just the open source community, but you're also a open content community, and that's why I think this is a very interesting combination to be here, because actually when I look at my work and at my research center for digital sustainability in Bern, we are exactly doing this type of research and teaching and consulting in the area of open source, in the area of open data, of open government, of net politics, and also procurement. So that's why I very much feel home here, although I'm from Switzerland, as you can maybe hear, and yeah, so I'm happy to be here. So what I would like to talk to you the next couple of minutes is some experiment. Basically, it's for the first time that I present these kind of slides, because I used to talk about open source, I used to talk about digital sustainability or open data, but I have not much combined them so far. So let's try and see how far we get. First of all, let me give you a very historic example of digital sustainability and why actually this idea is not new, although it might sound new. Then, as you might not have heard before of digital sustainability, just a question, who has heard of digital sustainability so far? 1, 2, okay, very few ones, but that's good. So I can give you a very short introduction to this sort of new concept. Then we will see how actually, where is the link from digital sustainability to open source communities, because there is some very interesting links between them elements, and then very much more focus on the open source community, very practical aspects, what makes open source community sustain for a longer term. So that's what I think is also very interesting for you as a community, and how to continue. But first of all, let us go back a little bit in history. I think it's good to be here in an archive. Who remembers this type of image? A few of you have heard of the pioneer plague. It's a very interesting example, because actually it shows very visually what actually means sustainable information, especially if we go into extraterrestrial life, and how can actually non-humans understand what is Earth and what is what are humans. So this plague was actually, it's a very little plague. It's 15 times 20 centimeters, and it's a golden, it's kind of aluminium with gold on it. It should last for about 400 million years, they say, for the physical structure. So this is sustainable, I think we can agree. And it explains without any letters what and very basic ideas of Earth. And the history about this plague is interesting. You can read it on Wikipedia, which of course I use a lot. So thanks very much for this type of contribution you do. On Wikipedia they explain very well. It was actually very shortly before the Pioneer mission was launched. One professor visited another, and they had the idea basically to put on a little sign, a little message from Earth on this spacecraft, and they had actually 3 weeks time to invent this type of communication. So what you see here basically on the you don't see my pointer, but what you see on the left upper side, this is a hydrogen atom, which changes its spin. So I'm not a physicist, but my dad explained it to me. So they change the spin with a certain frequency, and because hydrogen is the most common material in the universe, so it was supposed that maybe some smart extraterrestrial life forms are also able to know what is a hydrogen atom. It goes on that the rectangular sign is the kind of structure of the spacecraft, of the Pioneer spacecraft. So it shall show the size of humans, of men and women. Here actually there was also a political dispute in 1972 that NASA sent out pornography into the space, and there was a lot of discussion if the vagina of the female might be drawn with a little line or not. So you can read all that about this on the internet. And then there is also the idea of the position of the Earth and the solar system, and that's where they actually had like 14 pulsar stars, which have a certain distance and a certain frequency, how often they transmit electromagnetic waves, and that's these stars. And what I think is very interesting, already in 1972, when there wasn't much known about internet and digital and anything, they had the idea of transcoding information with binary information. So actually the hydrogen atom on the top, you see a very little sign in the middle of these two circles. This is a 1, and this is actually coming in the stars. It is basically shown, does this work? Maybe not. Anyway, so it's here. Basically, you see here, this is, if you look at it in detail, it shows a binary description of the distance of these pulsar stars and then how the frequency. So with this little image, and here again is the sun and the solar system. Here Pluto was still a planet back then, and then here the solar the spacecraft was sent out between Jupiter and Saturn, and so it shows basically where this spacecraft started. And there's much more information on this plaque, but it just explains very in a simple idea what is possible to make information sustainable and also understandable for people, not even humans. It was continued actually with a second, much more elaborated such information piece in 1977 when the Voyager spacecrafts were launched. It was much more elaborated in a way that they actually had a golden record. It is really a record, as you can play your records, the Beatles and so, but in this record there is a lot of information stored from analog but also in a way digitally stored. There are 116 images, there are natural sounds, there's classical music, spoken languages. Of course, the American president had some speech on it. And so this Voyager golden record, it's right now at the moment we assume it's traveling at 60,000 kilometers per hour, and it's about 20 billion kilometers away from Earth. So this information is actually now out in space, and I think it's very interesting. In about 40,000 years, these spacecrafts come near near another star, and here I think maybe someone will identify what is on there. What I think there is a lot of information or intelligence stored. But then, first of all, the idea is how can extraterrestrial forms of life read the information? So in this way, actually, the back plate here is describing how this record can be read. And here it's again using the hydrogen atom spin, using the speed of the record, how it is also a little record is stored on the spacecraft, how to actually, with the needle, how to read the information. And here the transforming of analog to digital information is explained. And if everything works, then you can see a little image. And here just a short view of the image which is stored on this record. You can see a lot of more images. Here is the image of the solar system, and again these pulsar stars. There is the decimal system explained very neatly. Also the binary conversion between 1 and 2 and so on. It is explained what are natural kind of metrics on Earth. It's explained what is the size of the sun and the planets. Then there is photographs. It's actually color photographs of Earth, and also from chemical compounds, from the DNA structure, and then actually it's explained what are humans and how they work, and basically even sexual organs are shown. It's explained how the life is starting with the sperms, and photographs from 1977 back then, how it grows life, how actually a little child is also born, and very practically how children are raised on Earth. Then there's natural elements. There's pictures from flowers and plants. There's different cultural background of people. Then there's animals in sea. There's houses. There is buildings like the Australian Opera in Sydney. Then there is other forms of transportation, and even airplanes, and of course also some astronauts being stored on this play record, and also some cultural background. So this is just give you an impression how much information is now traveling outside of our solar system to some other form of life. And this example actually made me think, so what do we need for digital for sustainability of information? Maybe not yet digital, but of information. So I think we need the data itself, the content, whatever is stored on this plate, but we need more. We need also a format which is explained, specified how this information is stored, and this is basically where the record describes this binary form of storing information. Then there needs to be an explanation how to read this data really physically. This is this recipe, basically, how to use the record player and how fast is the spin of the record. And then we need the hardware, the storage of the data, and then we need also players to actually play these type of hardware. So imagine when you have now some disk from the 80s. This is exactly the problem we have. We often have maybe the data on the disk, but we don't have the storage. We don't have the player actually to run the device. We don't maybe know the format of the data and so on. So to actually have a sustainable information, we need more than just the data itself. With this, let me now introduce you the concept of digital sustainability. Here, first of all, the origin of the term sustainability is also very ancient, even more ancient than the spacecrafts. So in the 18th century, Hans Carl von Carlowitz actually had the concept in the forest area to explain that farmers should only cut as much wood that the forest grows again. So if you cut too much, then there's no trees, and basically you don't have any wood anymore. But if you cut only as much as grows again, then it's sustainable. I think very simple, but very clear explanations. In the 80s, actually, the United Nations, they had a Congress, and there in the Brundtland report, it's explained and defined sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. In this context, the idea of sustainability was actually then used mainly in the idea of ecological sustainability, which I believe is also the most important way of sustainability, because without our environment, it doesn't make sense to make any spacecrafts or to work on computers if you don't have any air to breathe or water to drink. I think the hierarchy is quite clear. Nevertheless, then there's also the idea of social sustainability, where actually the human, the the workforce, for example, or also the human rights are in the center of the idea of sustainability. The idea of economic sustainability, that, for example, companies need to make investments so they are sustainable from economical perspectives, or states or cities or countries need to make economic decisions to be sustainable. And what I believe we are missing so far, and which needs to be introduced, is the idea of the digital sustainability. Digital sustainability is not my invention, but it's actually a colleague of mine, Markus Stapp, who defined it basically that the idea of sustainability from the ecological context is also transferred to the digital area. And so that actually nowadays we are in the era of the 70s and 80s, when there was a lot of economic growth in Europe and in Western economies, and then actually the first backdraws were recognized, so that, for example, nuclear energy is not as safe as anymore after Chernobyl, and it's not a way of sustainable in a good way. And that's when actually the idea of also the Brundtland report came up. And nowadays we are in the 80s of the digital era, I believe, of the internet, and we have some signs that show us that there are challenges in the digital area, and that's why I think, and Markus actually introduced this concept of digital sustainability. So basically it's exact same definition from the Brundtland report, but now applied to the digital area. And so the needs or the investments that we do today in digital assets and resources should not compromise the freedom basically of future generations. And here the basic idea is make the information, the digital resources, as accessible to the largest number and reusable with minimal restrictions, and it's applied on knowledge, on cultural artifacts in every digital form. In German, I wrote the Wikipedia entry some years ago. It was heavily disputed in the beginning because, as you might know, that in Wikipedia we should not coin definitions, but it should only have kind of referencing to existing definitions. So I had to fight a little bit until it got settled, this page. And but it's still missing an English translation, so if anyone has time and enthusiasm, so please help me. Important for the digital field is the classification of goods, because as you might have reasoned that in digital we cannot consume the goods, so it disappears as with the wood or with other natural resources. So basically the idea of this very traditional idea of economics to divide goods into rivalrous and non-rivalrous goods. So on the left side basically we have the physical world, simply put, and on the right side we have the field where actually it's something not consumable. And then there is the level of access. So it's excludable or non-excludable. And here, if we have on the left side, on the right side, sorry, the digital field, we can distinguish between club goods, which is, for example, proprietary software, proprietary data, proprietary standards, which is, although it's not rivalrous, it's not consumed. You can copy Windows or any other data as much as you want, but it's excludable. So basically, you're not allowed to, or you're physically or technically made not to do so. So basically, there actually the idea of public goods come in. And public goods obviously is open source, is open data, is open content. And here I think this is a very important distinction between physical world and also digital world, and between the proprietary field and the open field. Now I cannot go in the details. It's just a very short reference on a new conference paper I wrote for a conference later this month, where we have drawn the characteristics of digital sustainability. Also, again, using the literature from ecological sustainability applied on the digital era. So when we talk about intergenerational justice, or as this definition of the Brundtland report explains, here I think in the digital realm of content, it actually means that there must not be any legal obstacles or any other restrictions kind of hindering future generations to use the information. It must be, as with the Pioneer or Voyager Plaque, it must be also technically able that future generations can read the information, can read the data. Then there needs to be a regenerative capacity, and here the idea of the tacit knowledge is used. I will come to this in a moment, but I think it's also important that while in the woods, while in the forest, the wood grows, the trees grow. In knowledge societies, it's important that also the knowledge which is within our heads is basically being able to reproduce and applies to new contexts and solving new problems, or actually bringing solutions to new problems. And then there is the economical use of resources. So it actually, the idea of reuse of digital assets is important. The contrary would be any digital rights management where you can play your MP or your music file only once or only 10 times and you cannot copy it to any other device. Then there is the risk reduction, basically all the dependencies we have today. We have any states which are looking into our data. So here we need to be risk aware in a way that our data is safe and integer, and we don't depend on any company or any single persons. And then there's the absorptive capacity in a way that it's information flooding nowadays. When a lot of information is coming, we need to be capable actually making actually sense out of this big data, and here also this aspect is important, and that the ideas of the highest added value that the sustainable information should bring. And here I think it's important to have ideal policy conditions, so regulatory framework is important. So this is basically my proposal. I think it's a one way to look at, but maybe you have other ideas, other aspects which we can discuss later on. Maybe one question I would like to answer briefly with this example or this slide. Why don't we call it informational sustainability or knowledge sustainability, which in the end is the idea of the concept? I think it's the real mass amount of data that we are facing nowadays. In just a few years, we have grown exabytes of information. It's just one of the reports. There are many of them out of there currently in all the big data prospects of any big corporation. They explain us why we need to buy more storage devices and so on. There is another example, I think, from the US archives, where actually in 2010 they asked Twitter to basically hand out all the tweets which were sent out by then, and Twitter, nicely as they are, they agreed to hand out all the tweets and to hand out all the future tweets. You might know there are 500 million tweets a day, and so National Archive of Congress is now archiving all these tweets. It's I think 170 billion at the moment. And so this is the amount of data that we are talking of, and so that's why actually we suggest to use the term digital sustainability, because in the end we are handling data and not just information which is a little bit fuzzy. Yeah. Okay, so why is actually knowledge important, and why is actually also a community important with this whole concept? In this way, a very short introduction into knowledge management theory. There's one basic, very simple distinction between knowledge, forms of knowledge. So there's explicit knowledge, all knowledge which is actually drawn, documented. It's raw data, it's databases, it's any documents, it's any picture you take, it's any music you record. So this is called explicit knowledge, and it's very easy to transfer because you can copy it, you can maybe transform it a little bit and make other formats out of it, but it's all the knowledge which is kind of explicit. And then there is the tacit knowledge, this type of knowledge which is not yet documented, or which is basically in our heads, in our brains, which is stored also within communities, which is a kind of communal best practices, which are things, skills like you do skiing or you do biking. So you know how to bike, you know how to ski, but it's very difficult for you to explain it to someone who's not able to do it yet. So it's all this type of knowledge which is basically difficult to express. Also how to speak a language, how to express certain terms and so on. So here it's actually a sticky knowledge we talk of, and it's basically sticking in our heads and in our bodies. And then there's the concept of organizational learning, which is about how can organizations, companies, usually in research we talk about companies, how can they create knowledge, how can they acquire knowledge from outside contributors, how can they diffuse knowledge, how can they kind of absorb knowledge, and then there's the idea of transformation within knowledge. And here maybe also a final slide about knowledge theory. It's from Nonaka. It's a Japanese, very old Japanese professor. We had the possibility to meet him once. He's a very special person, and he had the idea in the 90s to actually make a very simple 4x4 diagram, which is the basic element of most of research papers. So basically, when we talk of tacit knowledge, it's basically in our head, in our community, and it's transferred basically from tacit to tacit knowledge. We call it socialization. So basically, when you come into a new group of people as a new community, basically you learn how they work. You learn in a craftsman where they make chairs and tables, or you work in a team of programmers. That's when actually the tacit knowledge is transferred through the process of socialization. When actually the tacit knowledge is transferred into explicit knowledge, we talk of externalization. So basically you have the idea in your head and you write it down. You write down your thoughts, and you write down some code, or you make pictures or draw pictures. Then there is the idea of explicit to explicit transformation. We talk of combination, so that new knowledge is created or through the combination. It's also about linked data, for example, in our terminology. Then there's the step of explicit knowledge transfer to tacit knowledge. Basically, when we learn something as an organization, as an individual, it's called internalization. So basically, when we read a manual, or when we cook a recipe, we cook something with a recipe and so on. So these elements describe the basic transformations of knowledge. And what does this actually mean for open source now? Here we also have this type of two knowledge. So first of all, we have the source code, which is obviously an open source. It's openly available. It's explicit. We have any content in any wikis. There is a lot of content inside. So this is all the explicit knowledge. But then there's much more. Then there's all the tacit knowledge, which is involved with this type of explicit knowledge. It's basically the know-how about the source code. It's basically to know when a bug occurs, how can actually you fix the bug, or why did you write it like this? So this is all the knowledge which is basically remaining in our heads. Within an open source community, there's a lot of collective intelligence, basically as a tacit knowledge. There is explicit knowledge, of course, all which is on the website, on the source code, but then there's much more basically within the community, in the people of the community. And it's also important not just to know how the code works, but also it's important how the components work together. And here we did some research about components within open source communities. And so you might know the Mozilla Firefox, which is this little box up there. And then if you use this very simple command on a Debian distribution, then basically you can draw all the reverse dependencies for this one particular open source tool. And then it brings you out a huge picture. It's much bigger than on this slide. It goes 10 meters in both directions and shows how many libraries, how many other components are necessary actually to run this Mozilla Firefox. Some of them are included directly into the Firefox. Some of them are on the operating system, of course. So it's just showing we build up on the shoulder of giants when we build open source. And here all the knowledge how to connect these components is within also the communities. It's barely a document. Well, it is document, of course, on only the package dependencies, but then there is a lot of knowledge within these distribution, within these Linux communities, how actually to connect these components. So that's basically the idea of tacit knowledge within open source and any open communities, and why this is important. Now, let me get a little bit more practical, as there was a lot of theory by now. I would also go into the idea now, what do we do with the idea of digital sustainability, of this knowledge theory? How is it actually applied within open source communities? And first of all, just let me point out, open source is growing. There is a good annual report. It's called The Future of Open Source. It's linked here on the slides. And basically my primary source of information how big open source is actually Plaque. It's a company from the US who is doing open source compliance checks for corporations like Oracle or SAP. So basically SAP can run their proprietary software and see how much license conflicts there are within the proprietary software, and so they can hit on the fingers of their developers, so actually they don't include any GPL code. So basically the idea, Black Duck has a huge knowledge base, and in this knowledge base they actually store not just the source code of every open source project they find on SourceForge or GitHub or any other platform, but also they store every version of the source code. So basically they have a gigantic pool of information about open source, and so they also know that nowadays we talk about 1 million open source projects. In maybe 1 year it might be already 2 million. So it is growing massively. It doesn't mean that every open source project is like as big as the Linux kernel or anything else, but it just shows how big the universe is basically. Now with this idea behind, I think it's important that we think about sustainability of communities and what makes them sustainable. Here is basically my 5 suggestions. What I think from my experience is making up a good community. There's much more written about this. I can recommend the OSS Watch platform in UK, in Oxford. They have the basically a competence center on open source, and also do some practical writings and about building communities. My master thesis 10 years ago was about open source community building, so it's very much on my heart to make communities grow happily. So let me bring you the first idea, or my first point is basically good governance. How basically are communities governed by some management team, by some board of directors, by some central group of people, whatever you call it. There is definitely some basically kind of spokesperson or someone in the end who has commit access to some source code repository or has access to some server. So these people are actually required to make good governance within their community. What does this mean? There's a lot being written. It just basically means that the processes are transparent, that there's no decision made in basically dark rooms, but then there's also participative culture, so that contributions from other people are included if there are any worth and quality is sufficient, that there is participative culture, also meaning that you can participate in decision-making processes and so on. So it just means basically everything what I think is within the term of fair management of a community. One research we did was about the Eclipse community, which was launched in 2001 by IBM. And here we actually saw that in the beginning there was, we actually distinguished between IBM and non-IBM committers of Eclipse. And in the beginning there was mostly IBM people. And suddenly after 2004 the external contributors grew much more. Actually nowadays it would be even bigger. We stopped our research in 2007. We should do maybe some update one day, but at the moment it's much higher, I suppose. And the idea is basically in 2004 IBM not just had the source code opened, which is the explicit knowledge basically, which everybody can fork and you do whatever you want, but they also opened up the governance structure. They actually formed the Eclipse Foundation. They did some non-profit legal umbrella around the Eclipse community and actually defined whoever pays so much money can participate in this board of directors. And suddenly all the corporations like Google and Oracle and others, they had the trust that they actually were able to influence not just the programming part, but also the strategic direction of the community. So this is just one example. A bad example is when basically communities fork. Forking, you might know, is basically when mostly about governance is not being done correctly and fairly by the initiator of the project or other some central players. It's basically unfriendly separation of the community. Mostly, I must say, because there's some friendly forks. But then it's also important, I think, it's very important forking in communities, because actually it shows that you must behave good and you must do good governance within the open source communities. If not, then the community forks. It splits up, and here we have a lot of examples. One of the examples just recently was this OpenSSL Heartbleed thing, when suddenly the LibreSSL community was formed. This was basically a fork in a good sense, that they said that let's start something new, although now it might make sense to merge them back again, but in the moment I think it was a very good decision. Then there are much more forks from Nagios, Isinga, and the MySQL fork, when MySQL was bought by Sun and later by Oracle. Then the original, the inventor of MySQL actually formed the MariaDB fork, and there were more forks actually out there. There's a very old one, the Mambo. Probably no one knows Mambo anymore, but a lot of people use Joomla. So there are a lot of forks, and the one fork I'm a little bit involved in is the OpenOffice thing, because here we'll see that there is some experience I did. So OpenOffice was actually also was part of Sun Microsystem, and when they were bought by Oracle, basically the community split up into LibreOffice, and after that OpenOffice, Apache, Oracle donated their code to Apache. The history in detail is a bit more complex, so there's much more forks were done actually in the history of OpenOffice. But just to show you, basically, forking is part of a community, but it's not a good sign, but it's basically a signal of bad governance. when we see then one research paper which was written about the forking of the OpenOffice community, we see also the effect which a fork can have. So a fork is also always a little bit a risk. Who joins the fork? Who actually does the runaway part, and who actually sticks with the old project? So basically the researchers, they actually looked at who was within the OpenOffice community.org back then. There was these 209 committers. The vast majority actually joined the LibreOffice community, which actually grew 553 new contributors within the last 2 years. And also very little contributors from the OpenOffice.org project actually went over to the Apache OpenOffice project, which is nowadays quite small and basically consisting of the people at IBM working in Hamburg on the OpenOffice distribution. So nowadays the music plays within the LibreOffice community, and you can see this in several statistics. One other good form of knowledge is the OpenHub, the former Olo.net platform. So here you can compare communities between each other. You can see, basically say, I want to see who is actually doing LibreOffice development, who is doing OpenOffice development, who are the contributors, for example, the last 12 months. There are these developers and much less in OpenOffice, how many commits were made, how many files were modified, and so on. So you basically see in every single statistic, LibreOffice is at least double as, or much even more bigger than OpenOffice. So this is type of the consequence of a fork. I don't say that it says something about the quality of the fork. At the moment, I'm very unhappy with LibreOffice because it crashes my presentation. I actually had to write this presentation on OpenOffice, but I assume that within the long term, if you look at sustainability, the future will be within the LibreOffice community. And we organized in September the conference in Bern, and I'm very happy about this community, and I think it's a very healthy community actually. What else important for communities? Heterogeneous, the diversity within communities is very important. There's a very beautiful YouTube film about the Linux development, which I won't play now because time is running up, but you can watch it on YouTube, how development actually takes place within the Linux kernel. And Linux kernel is actually said to be the largest cooperative software project ever on Earth, and because you can see that there is a huge development going on, and it's very heterogeneous. So the largest contributor is actually Red Hat, which you can see is contributing within the last, basically within 1 year, it's basically only 10%. So even if Red Hat, the biggest contributor, leaves the community, a lot of developers stay within the community. You can see here how much every company has contributed, how many commits to the Linux kernel within this time span. It's actually, the report is done by the Linux Foundation, and they actually do a lot of statistics also. They explain, like, they say that since 2005, nearly 10,000 individual developers who are working on the Linux kernel, and from over 1,000 companies. So you see how broadly dispersed this community is. And it actually also shows, for example, that 80%, or probably even more, are employed Linux contributors. So it's not just a students project anymore as it started 20 years ago, but it's now really a highly professional community. So why actually do developers, individuals work in open source communities? There's a lot of research about this type of question. My favorite paper is basically the summary paper, which summarizes about 30 research papers about open source motivation. And it comes up basically with 10 different types of motivation. It shows that motivation is going from completely intrinsic motivation towards completely extrinsic motivation. So intrinsic motivation coming from the inner happiness of a person, doing it out of ideological reasons, of altruism, giving back, kinship, being within a community like here, doing it for fun or also for reputational reasons, up to a more extrinsic motivation. So if you give, I have received from you, so that's why I give back to you, that's reciprocity. There's learning motivation, that you learn a lot and it benefits to you, but this is called more actually extrinsic motivation. It's own use, that you have a problem and you solve it, or that you have a career you want to improve and that's why you contribute to some projects and hope that Google or some other company actually hires you. And then there is of course the pay, so you are paid basically to do certain things. And I think it's very important that within a healthy community there's not just one type of motivation, but there are different types of motivation. Every one of us also have not just one single motivation, but maybe one factor is more important than others, and maybe also it changes over time. So someone who used to do it for ideological reasons suddenly gets discovered by some company, and then he gets hired. And then he works out of more explicit extrinsic motivation. So I think it's important to have also a heterogeneous community in this sense, and that actually the community governance body, like the management team, thinks about also honoring all these types of people. What I think is also important to have some central non-profit organization around it. We have seen this in a lot of large communities or a lot of healthy communities, that there is some association, some foundation working on this type of sustainability. The association takes care of legal issues, of community events, of some documentation, also some websites and so on, all the infrastructure, and also about public relations and marketing. And marketing, I think, is very important, because if you look at IT industry, and especially software industry, marketing is actually key to everything. If you look at the annual reports, which are publicly available for stock market companies, for example, Adobe spends double amount of money for sales and marketing than for research and development. Or the same is with Apple, the same as with Oracle, and also Microsoft spends much more for sales and marketing than actually for the development of their software. And I think that is something which make us a little bit, which is a little bit scary, I think. But on the other side, it should also motivate us as open source communities to invest more in marketing. Ecosystems of commercial service providers. I think it's important for especially professional users that there is some availability of commercial services. Here there's a lot of literature about business models with open source. This is just the one possible set of open source based business models. Important is also to actually show it to the world that you have a company and that you provide services. That's why we at Swiss Open Systems User Group, we have started this open source directory 10 years ago, and actually re-implemented it a few years ago. There's a Swiss version, .ch, but then we have also reserved all other domains, so .at also exists. So Austrian companies are invited, or French companies are invited to register their company, to actually say what products they support, what open source projects to provide service for, and also to document what clients they have served so far. So we have several hundreds of entries so far. It's 150 unique visitors a day and about 800 views of the platform a day. There's a lot of more open source OSS Directory.ch with a French translation, and the English translation is coming next year. Now, why open source communities actually work and also companies can earn money. This is another theory, but probably time is a little bit short, because I would like to explain the last point. I think it's also very important that users of open source project have the opportunity to influence development, or at least actually get their demands or their things done. When you remember the slide of the different motivations, here there's the one idea of paying developers, and I think there is the idea of Eric Raymond's book Cathedral and Bazaar, that the developers in open source do what itches them, what actually then they scratch and they solve their problem. But maybe there are problems which are not itching that much to the developers, and that's why actually users should also have the opportunity to get their itches being solved, although maybe there's no user and no developer yet. There's a very simple platform, bountysource.com, and some other open source bounty platforms where communities or actually users can do some competition, like who actually implements me this certain feature request for, let's say, $1,000. So here, for example, GitHub actually wants this solution being implemented for $1,000. IBM puts out $1,600 for some implementation, but then there's also little issues, little bugs, which someone is actually willing to pay something. And here I think it's very simple but straightforward form to invest some money and get things done. The other idea is basically that communities themselves implement some bounty system. There are a lot of examples. I know ILIAS E-Learning System, they have done this so far. So basically as a user you can suggest new features and then actually say that you are also willing to pay for this feature. And hopefully your feature are being implemented. So here basically you see what the University of Bern has paid for being implemented in this e-learning system. And then there is the institutional crowdfunding possibility that basically users join together and describe the specification commonly. And here we have the collective action problem, and that's when actually users cannot solve their problem without any help external. So that's when they actually form a group. We did this with the Open Source Business Alliance, formed this group of Office interoperability, and actually did this process from the initialization phase towards the funding phase and then the implementation phase. It started in 2011 when actually different public institutions came together. We did some workshop where actually we solved all these challenges we have between developers and users. So it's not a very easy task to solve this, but then after 2 days, basically we had these use cases together. We put out the specifications, and then in the end, 2 companies actually offered to implement it for €150,000 to implement these interoperability improvements. And nowadays, when you download LibreOffice, basically you can benefit of a better interoperability. Everything open source, of course, so you can see this also on the website. Now, just to round up, my not very intelligent, but maybe still some devices from my side, going back to these 5 types of community elements to make community prosper happily. Manage your community in a fair way. Don't exclude anybody, but play fairly. Foster diversity within your community. Be supportive if someone wants to make a business, and don't basically say that making money is bad. Empower a central office in your community, that basically somebody is taking care for all these marketing issues, for example. Try also to build up some commercial service provider environment so that companies can serve customers and that people are paid to work long term. And last but not least, also provide some feature request market or some other form of user influence possibilities into your community. And then I hope your community will also continue to fly for millions of years, as this Voyager is doing, hopefully nowadays, if it's not being hit by a meteor. Thanks.